Hi everyone, welcome to this video lesson for 1.7 functions. So what you're going to learn today is function notation along with how to evaluate functions when you're given a value for x and you need to find the value of y. So a quick review, f of x means the same as y equals. So f of x equals means y equals. So instead of f of x, you can replace that with y. Okay, so this is a y value. And then using f of x shows that the equation represents a function. So since the equation y equals to x plus 3 is a function, we can instead use f of x equals to x plus 3. And to find f of negative 1, which means when the value of x is negative 1, all we have to do is substitute with negative 1 into the equation wherever we see an x. Okay, so with that said, I'm going to go over the next example. So notice that I've used red if it's f of x, and green if it's g of x. So for example, number 1 says find the value of y, which is f of x, when x is equal to negative 1/3. So what I'm going to do is I'm going to substitute here. So f of negative 1 over 3 is equal to negative 1 over 3, close a parenthesis, take the square, plus 4 times 1, negative 1/3. Okay. So then here you're multiplying a negative times a negative, which means you're multiplying negative 1/3 times negative 1/3. And then plus, this is like saying 4 over 1, right? So if I multiply 4 over 1 by 1 over 3, then this actually changes to minus 4 over 3. Negative times negative is positive. So then this is positive 1 over 3 times 3 is 9. And then minus 4 over 3. Then notice that I need a 3 here, a 9, not a 3. So then I'm going to multiply by 3 over 3. Okay, so 3 over 3. So I can get a denominator of 9. So I can combine these two. So then this becomes 1 over 9 minus 4 times 3. That's a 12. And 3 times 3, that's a 9. Now we have the same denominator, right? So then all we have to do is combine the numerators. So then this is negative 11/9. So when x is negative 1/3, so this is f of negative 1/3. When x is negative 1/3, y is negative 11/9, or 11 over 9. So this is the answer to that problem. All right, so for the next example, notice that this is g. So then what that means is that wherever I see an x, I'm going to substitute with, instead of x, 7 over 12. So then g of 7 over 12 is equal to, there's a 5. So there's that 5 minus 3. And then instead of this x, 7 over 12. So 7 over 12. So then this is equal to 5, negative 3 times 7. Again, this is implied to be over 1. So that's minus 21 over 1 times 12 is 12. This is implied to have a 1 in front under it. So then multiply by 12 over 12. And I'm writing small here, but I hope you follow what I'm doing. So multiply by 12 over 12. So we have also, instead of 1, we have a 12. Okay, so this was covered on the lessons from last week. So then 5 times 12 is 60. And 12 times 1 is 12 minus 21 over 12. 60 minus 12 is 39. So 39 over 12. Okay, now see if we can simplify this. So 3 goes into 39 13 times, and 3 goes into 12 4 times. So then this simplifies to 13 over 4. Okay, so then f of 7 over 12 is 13 over 4. Now we can write the coordinates. So the point is, where x is 7 over 12, y is 13 over 4. And this is the answer to that problem. So far I hope you understand. They give you the x value, you need to find the y value. Okay, so let's go on to the next example. So for this one, I'm going to say with green again because it's the same function g. So then this is g of negative 2/3 is equal to, there's a 5 again, so I'm just copying what I have here on the paper. So function g is 5 minus 3x, so 5 minus 3 times negative 2/3. So then, as you know, this 3 and that 3 reduce. If this 3 becomes a 1, this 3 becomes a 1. Negative times negative is positive, so then this becomes 5 plus 2, which means g of negative 2/3 is equal to 5 plus 2, which is equal to 7. So then for this one, we're given that x is negative 2/3, and we just found that when x is negative 2/3 in this function, y is positive 7, and this is the answer to example number 3. Okay, let's go on to the next two examples. So what if they give you something like this? So they give you find f of negative 1 plus g of negative 4. So what you do is you go to this function, wherever you see an x, replace that x with the negative 1 squared, then multiply that by 2 times negative 1, and then go to g and replace this x with the negative 4. So that's what I'm going to do next. Okay, so then what I'm going to say is that f of negative 1 plus g of negative 4 is equal to, I'm going to look at this function, so that's negative 1, square it, and then plus 4 times negative 1, and then it says add, so plus g of negative 4, so I'm going to go to g, and this is 5, and let's see for this one, minus 3 times negative 4. So this one is a little bit long, but watch, see if you can follow the process here. So negative 1 squared is the same as negative 1 times negative 1, which is positive 1. And then this is plus 4 times negative 1. 4 times negative 1 is negative 4. So this is 1 minus 4. And we have the plus 5. And then we have negative 3 times negative 4. Negative times negative becomes positive. So this becomes plus. 3 times 4 is 12. Now combine 5 and 12. They combine to 18. 1 plus 5 is 6. 6 plus 12 is 18. But 18 minus 4 is 14. So then f of negative 1 plus g of negative 4 is equal to 14. And that is the answer to this problem. Okay. All right. Same reasoning for number 5. F of negative 2. I'm going to do this one differently, so I hope you can follow. But it's the same process, and then you choose which one you want to do. Okay. So let's find f of negative. I'm going to do this with red. So I want you to see it different ways and see which one you feel more confident with. So let's find f of negative 2, and that equals, so I'm going to go to this function here, the function f of x. So this is negative 2 squared plus 4 times negative 2. And this is equal to negative 2 squared is 4. 4 times negative 2, that's negative 8. So then this is equal to negative 4. Now let's find g of 4. So this is minus, right? So then we have g of 4 is equal to 5 minus 3 times 4. 3 times 4 is 12. So this is 5 minus 12. So then we have 5 minus 12 is negative 7. Now let's find f of negative 2 minus g of 4. So then this is equal to, we know f of negative 2 is negative 4, but then be careful here, this is minus, so minus, now watch what happens here. We have a negative 7, this negative and that negative become positive, so this is negative 4 plus 7, which means f of negative 2 minus g of 4 is equal to negative 4 plus 7, which is equal to 3. And that is the answer to this problem. Okay. Okay, last part of this lesson. So this is a vertical line test, which we mentioned on the previous lesson for domain and range in set and interval notation. So the vertical line test, or the VLT, states that if a vertical line passes through more than one point on the graph of a relation, then the graph is is not a function. Okay, so this will be fast. Use the VLT to determine whether if each graph represents a function. 1, yes, because you can draw as many vertical lines as you want and it'll pass that test. 2, this one, there's just that example, the answer is no, because the vertical line passes or crosses this graph at two different points. Okay. 3, you can do as many as you want, and this will pass every single one of those tests. So, and that is all for this lesson. I'll see you in class. Thank you for watching. Bye-bye.